Well, welcome back to Math with Murphy. In this video, we are going to be looking at the graph translation theorem. Now, basically, there are a lot of different types of transformations, and all a transformation is a change in our graph. Now, some of those changes could stretch our graph, it could shrink our graph. Those are called scale changes. Other transformations could move a graph left, right, up, or down. And that is what we call a translation. So that is what we're going to be focusing on today. So let's watch this video and see that you can understand how to do a translation by the time this video is finished. But first, let's look at some graphs and see how this is all going to play out. So let's look at this first graph. So this first graph is of our parent function, y equals x squared. Now, if I told you that we were going to graph x plus 3 squared, and that would move the graph horizontally, left or right, I want you just in your head to make a guess as far as which direction that would move. Do you think that would move to the left 3 units, or do you think that would move to the right 3 units? Let's look what happens. It actually moved to the left 3 units. Now, I know our brain wants to tell us when we see that this is, plus 3. Ever since we've been a kid and we first learned about a number line, or when we first started graphing, we learned that the positive direction was to the right and the negative was to the left. So anytime we had positive numbers, that means we'd go to the right. Well, for these problems, anytime we have something happening directly with the x, we actually have to stop ourselves and do the complete opposite of what our brain is telling us to do. So when it says x plus 3, we actually want to translate the graph 3 units to the left. And you might be wondering, why would that be? Well, if we think about it, here's our vertex at 0, 0. Well, if I put negative 3 in here for x, negative 3 plus 3 is 0, and 0 squared is 0. So when x is negative 3, y is 0. If I put positive 3 in here, thinking that, well, when x is 3, what will that be? Well, 3 plus 3 is 6, and 6 squared is 36. So it's going to be way off my graph. So anytime now when we see plus with the x happening directly with the x, that means we have to stop and do the complete opposite and move to the left 3 units. So let's think about this one. If I had x minus 2 quantity squared, what's going to happen there? Well, hopefully now you're able to recognize that this is actually going to move to the right 2 units, which is what happens. Now let's say if we have something completely separate. So here we have x squared plus 4. So the plus 4 is after the squaring. And if I told you now that that would move the graph vertically up or down, which would you guess would happen? Now maybe some of you guys are stumped because at first you wanted to say that it's going to go up 4. But now you're starting to second guess yourself and maybe you think you're supposed to do the opposite and go down 4. Well, let's see what actually happens. Look at that. It moved up 4. So in these situations where you have something happening outside of the square, or if we're working with other types of grouping symbols like absolute values, square roots, and so on, we'll look at some other ones here in a little bit. But whatever's happening outside of the quantity x, that's going to affect the graph vertically, and it happens exactly as we'd expect. So when we see plus 4, it is actually going to move the graph up 4 units. So when we see x squared minus 3, guess what? It's going to move the graph down 3 units. Well, let's look at this last one. If I had x minus 4 quantity squared plus 2, we're going to have 2 things happening at the same time. So first, is this graph going to go to the right or the left 4? And then, is it going to go up or down 2? Well, hopefully you're saying, oh, that's right, we got to do the opposite with this. And even though my brain says I want to go to the left, I have to do the opposite. I want to move to the right 4 units, and then this is going to go up 2. So let's check, and sure enough, the vertex moved to the right 4 units and up 2. So let's go back to our notes now. So let's see if we can apply what we just learned to be able to answer these questions. So here in this first question, it says, give the equation of the graph for f of x equals x squared that has been translated 3 units to the left and 1 unit up. So for this type of problem, again, we got to think, with the x, we have to do the opposite. If we're going to move it 3 units to the left, that means that we're going to have to add 3 to just the x. And if it's going to go 1 unit up, we're going to have 1 unit being outside of that quantity. So we would have x plus 3 quantity squared plus 1. Let's look at the next example. What would be the vertex of the equation y equals the quantity x minus 4 squared plus 2? So we have to think, how is this parabola going to be translated? Well, the x minus 4, we do the opposite. It's going to go to the right 4 units. And then the plus 2 means it's going to go up 2. So the vertex, if we move it to the right 4 and up 2, that vertex now is going to be at the coordinate 4, 2. Well, everything we've talked about could apply not just to parabolas, but for any of those parent functions that we saw in the previous lesson. So let's look at these boxes here with these 7 parent functions. Now, I'm going to give you some formulas here that's going to show you how we can apply these translations. And we're going to use the letter H to represent a horizontal translation, and we're going to use the letter K to represent a vertical translation. So you might want to pause the video and copy all these down. But here's what I want to point out to you. Notice that for all of these problems, we have a grouping symbol. Over on the left over here are grouping symbols. We have parentheses, we have the square root, and we have the absolute value. And the plus h is happening within the grouping symbol. So again, with the x, we always have to do the opposite of what we expect when we talk about how the graph would look, or how the graph would look in comparison to the parent function. And then outside of those grouping symbols, we have the plus k, meaning that's going to affect the graph vertically up or down, and that's going to be exactly as we see it. Now over on the right here, we don't have some of those unique grouping symbols. I guess we do have parentheses here, but you got to remember that the fraction bar also acts as a grouping symbol. So we have x plus h in the denominator there, so that would be how the graph would be affected horizontally, and the plus k is outside the fraction. Now for an inverse square, we would have parentheses there around the x and the h to show that the whole quantity is getting squared. And then lastly, we have our exponent. So in this case, our exponent is going to be x plus h. So again, whatever happens directly with the x, we have to do the opposite on our graph, and then the plus k is exactly as we would expect. So let's go to the next page and look at some more examples of how we would graph some of these different translations out. Okay, so for these first 2 functions, we have our square root as our parent function. So we have y equals square root of x minus 3 plus 4. Now, even though this isn't a parabola, the same rules apply, just like we've been talking about. So here inside your grouping symbol, the square root, we have x minus 3. So that means we're going to have to do the opposite. We're going to go to the right 3 units, and the plus 4 means we're going to go up 4 units. So remember, the square root function has a distinct starting point. Originally, the parent function, it would start at 0, 0. Well, now that starting point is shifted or translated to the right 3 units and up 4. And then the graph would be this arch going up and to the right. And that's what I want to see when I go to correct your work on your quiz or on your test. I don't need to see that the graph is perfect. I just want to see a good sketch of a graph. Now let's talk about the domain and range. Now we're going to have these in what's called interval notation, meaning we're going to use brackets and parentheses, and possibly even the infinity symbols. So for this graph, the domain, the smallest value on the x-axis that's being used is 3. And then we're using an infinite amount of values to the right of that value 3. So the way that we can identify the domain is using a bracket at 3 to indicate that 3 is included. And then we'd have infinity, meaning everything to the right of 3 is also part of our domain. Now our range are the values on the y-axis that are being used. And the smallest value on the y-axis is 4, and it goes infinitely up. So 4 is included, so we would use a bracket there. Now we're going to go through and do the odd problems together. I'm actually going to skip through, I'll go through 3 pretty quickly because we've done a lot with parabolas. But I'm going to have you guys do the evens on your own in a little bit. So let's not worry about number 2. But let's look at number 3. So just remember the graph for this one, we would move it to the left 1 unit and up 5 units. So that would be your vertex. Here's our parabola. Our domain would be all the numbers on the x-axis. So we identify that using parentheses saying negative infinity to infinity. And our range has a distinct starting point starting at 5 and goes infinitely up. So let's talk about this next one. Remember, this parent function is an absolute value function. And I always emphasize when I say this name, absolute value, on the v, because our graph is going to be in the shape of a v. So for this v, the vertex of this is going to move to the right 6 units and down 2 units. So if you see that little red dot there, that is where our vertex is going to be. And from that point, we're going to draw our v. So it should be 2 straight lines, as straight as possible, in the shape of a v. Now remember, for this next one, the parent function was this kind of a zigzag line that would go through 0, 0. So it looks something like this. Now we want to take that point, the origin, and we're going to translate that origin to be at its new location. So again, it's plus 2, so we're going to go to the left 2, and the minus 4 means we go down 4. Oops, I'm sorry, we forgot to talk about the domain and range for the absolute value. So the absolute value, the domain would be from negative infinity to infinity, and the range would be from negative 2 to infinity. So it's done very similar to a parabola. So anyhow, for this one, like I said, the vertex, or not the vertex, but that point where the origin would have been, has now been translated to the left 2 units and down 4 units. So now your little zigzag line would go through that point. Okay, so now let's talk about this one. So here we have our inverse variation problem where we had y equals 1 over x would be your parent function. So I do have on our graph here the original asymptotes. Now remember, the asymptotes would be your vertical line at x equals 0, and our horizontal asymptote is y equals 0. And when we translate this graph left, right, up, or down, it's going to move these asymptotes. So for example, the x minus 2 means that we're going to translate this graph 2 units to the right, which means this vertical asymptote is going to move, oops, I forgot to do the domain and range above. You can see there, it'd be from negative infinity to infinity, and your range would be from negative infinity to infinity. Anyhow, but for this graph, for number 9, our vertical asymptote is now going to be at x equals 2, because it's translated 2 units to the right. Our horizontal asymptote is going to move up 3 units to be here. Now remember, the y equals 1 over x, the graph for that was in quadrants 1 and 2. The graph for this one, even though it's been translated, would still be in those same regions. So it would look like this. So that is what your translated graph would look like. Now let's talk about the domain and range. Look, I didn't forget this time. The domain for this one is going to be that bottom left corner. We're going to start with that section. And that is going to go from negative infinity to 2. But as it gets to 2, notice how it branches away. It breaks away from where 2 is, because x can't be 2. The reason why is if you put 2 in here for x, 2 minus 2 is 0. Well, you can't divide by 0. So x could never be 2. So we have a parentheses there at 2 saying that 2 would not be included. Now we're going to include with that domain, so it's going to be the union with this other branch. This other branch is still part of the domain. And that starts again at 2. Again, 2 is not included, so we use parentheses, and then continues on to infinity. So that is your domain. Our range comes from negative infinity, and then it does kind of the same thing. It branches away when we get up here to where y is 3. So our range is going to go from negative infinity to 3, and then it starts back up here. This other branch, this other region, starts at 3, but 3 again is not included, and it goes infinitely up. So that would be your domain and range. So what I want you guys to do is I want you to pause this video and go through and do these even problems. So if you don't have my notes, maybe copy down these equations. And then I want you to now pause the video and go through and do each of these on your own and hit play when you're ready to check to see if you have the correct answers. Okay, let's see how you did. So with this first one, we have the square root function, so it's going to be very similar to number 1. So this one, it was going to go to the left 2 units and down 3. So you check your graph and check your domain and range. For number 4, we've done a lot with parabolas in this video, but this graph would go to the right 4 units and down 2. And your domain would go from negative infinity to infinity, and your range would go from negative 2 to infinity. So get number 6. So number 6 is another absolute value function. So the v would be translated 5 units to the left and 1 unit up. And here would be our domain would go from negative infinity to infinity, and our range would start at 1 and go up to infinity. Now let's talk about number 8. Number 8 is kind of tricky. So in number 8, our original function would be this parent function down here in blue. It would have a horizontal asymptote at y equals 0. And remember, it had a y-intercept where y was 1. Remember, every point is translated, including that y-intercept. So that y-intercept is going to move to the right 3 units and up 4. So you want to include that point, just to give you an idea, so that way your graph, again, it doesn't have to be perfect, but there's some things that we have to be kind of accurate with. And so having that point will help ensure that our graph is accurate. And then that horizontal asymptote at y equals 0 is going to translate up 4 units. So we want to make sure we include that asymptote in there because it gives us a boundary for our line. So when I sketch my line, I'm not going to go below where y is 4. Because if on a quiz or a test, if your line does go below where y is 4, you're going to lose points because that is not accurate. And the last one is an inverse square curve. It's going to have similar properties to number 9, where we have 2 asymptotes, a horizontal and a vertical asymptote. So in this one, our vertical asymptote that was at x equals 0 is now going to move to the left 3 units, and our horizontal asymptote is going to move down 2 units to look like this. Now remember, this one here is in quadrants 1 and 2, the parent function would be, so it's still going to be in those 2 regions. And our domain would go from negative infinity to negative 3, and then from negative 3 to infinity. But our range for this one, we don't have any values down in the bottom 2 quadrants, so they're in the top 2, starting where y would be negative 2 on up, but negative 2 is not included. So we would have parentheses at negative 2. So those are some examples with working with graphs, with graphing our functions. Now in the next examples, we're going to be looking at a description. So they're going to give us a description, and we're going to come up with the new equation. So let's look at these that I circled 2, 4, and 6 for right now. So let's look at number 2. It says an absolute value function with the vertex at negative 7, 12. Well, remember, an absolute value function looks like this. Y equals absolute value of x. So even though it doesn't ask us to write down the parent function, at the beginning it kind of helps to include that. So now we want to have the vertex of that at negative 7, 12. So it's going to go to the left 7 units and up 12 units. So our equation, since we're going to go to the left 7 units, has to be x plus 7 inside the absolute value symbol, and then plus 12. So we get number 4. So number 4, it says a cubic function has been translated 5 units to the right and 7 units down. So a cubic function, let's start there. Oh, I'm sorry, I was looking at the wrong one. An inverse square curve with asymptotes at x equals negative 4 and y equals 6. So the inverse square curve is at y equals 1 over x squared is our parent function. So the asymptotes are now going to be at x equals negative 4 and y equals 6. X equals negative 4 means it's a vertical line going through where x is negative 4. So that vertical line has translated 4 units to the left. And the horizontal asymptote has moved up 6 units. So the way we'll write that is x plus 4, parentheses squared, and then plus 6. Lastly, our square root function. So remember, the square root function looks like this, is going to have a domain going from negative 4 to infinity and a range from 3 to infinity. So this one's worded a little bit differently as well. So with this one, if our domain starts at negative 4, that means it's translated 4 units to the left. And if our range starts at 3 and goes up to infinity, that means it's been translated 3 units up. So let's look at that equation. So it'll be x, the square root of the quantity x plus 4, and then plus 3 outside the root. So I want you guys to go through and do the odd problems, do 1 through 7 odd. And so go ahead and pause the video and hit play when you have the correct answers to check to see how you did. Okay, let's look at number 1. So number 1, you should have had this, quantity x minus 3 squared plus 8, because it's going to move 3 units to the right and 8 units up. For number 5, for number 3, we would have an exponential growth problem. And I should have been more specific. Our base would be 2, Technically, with exponential growth, we could have a base of 2, 3, 4, 5, anything. Typically, we'll just keep it simple and use 2 as our base. But we would have 2 to the x plus 8 then minus 2. And number 5, your cubic function, we'd have y equals the quantity x minus 5 cubed minus 7. And lastly, number 7, we would have y equals 1 over x minus 3 minus 9. Well, there you have it. Hopefully, after watching this video, you have a better understanding of how to work with the translation. Now, before you close out of this video, I have been asked to request that you like this video and subscribe to my channel. Maybe by doing so, you'll become just a little bit more smarter. So with that, good luck now as you work on your assignments.